In this video we'll talk about equations for parallel lines and how the two are related. So before we get too busy into the nitty-gritty here, let's take a step back and let's look at a couple of parallel lines. What we have here is y equal 2x underneath and y equals 2x plus 1 up above. And I think we can agree these lines are parallel, and something that's worth noting here is that both of these lines have a slope of 2. It's just been shifted up 1. So parallel lines have the same slope, but they also have different y-intercepts. So it's worth mentioning, and this can actually help us in a lot of ways. But the idea is if they're parallel, we have same slope. That's the key takeaway here. So let's dive right into an example. Let's say I wanted to create an equation for a line that passes through the point -5, -8, and is parallel to y equals 3x plus 12. Well, if we look at this, I know parallel lines have same slope. So it's parallel to this one, and 3 is the slope. So this already tells me my slope is 3 for whatever line I'm doing here. So I know that y equals 3 times x plus b. Now me personally, I like using slope-intercept form to make my line, and I'll go through that method first, and then we'll talk about point-slope form. So I know that when I plug these points in, -5, -8, this equation has to be true. It has to work. So -8 has to equal 3 times -5 plus b. Now, I can use this to solve for b. So I have -15 here. I add 15 to both sides. This tells me that b has to be 7, which tells me an equation for this line would be y equals 3 times x plus 7. That would be the slope-intercept method. Now, if you're a fan of point slope, what you can do here is you can just go ahead and jump right in. We already know the slope, so we can just say y minus a -8 is equal to 3 times x minus a -5. And we could simplify it a little bit. We could get rid of the double negative, so we could say y plus 8 equals 3 times x plus 5. This would also work. It's an equation that is the same. These two equations are equivalent. If I was to manipulate this green one to get it into slope-intercept form, it would be this one that I have in blue. They both will work. They both are equations that can describe that line. And the key takeaway here is that parallel lines have same slope, and we can use that to our advantage. So if they're telling us that a line's parallel to another line, well, then we can just go ahead and extrapolate. Oh, that's the slope. If I can find the slope for the one line that it's parallel to, then I know the slope for the line that I'm trying to create. And then we can use that to make our equation.